Hi students, today our topic is, today I am going to discuss about accelerated motion in the chapter kinematics. The topic is accelerated motion. Right, accelerated motion is one of the topic in the chapter kinematics. Right. Before going to this, first what is meant by motion? Already you have to study it in the previous classes, and also you have to study it in the lower classes also. Right. What is motion? Or when an object is said to be in motion? Simple. If any object is continuously, if the position of any particle or any object is continuously changes with respect to time or continuously changes with respect to surrounding, then the object is said to be in motion. Once again I repeat, if the position of the particle is continuously changes with respect to time or with respect to surrounding, then the particle is said to be in motion. Right? This is a simple definition of motion. Right? For example, let us consider this object. At a time t equal to 0, this is a position of the particle. Suppose the particle is moving like this. Right? Okay. Here the position of the particle is continuously changes with the time. If time t equal to 0, the position of the particle is here. After 1 second here. After 2 seconds here. After 3 seconds here. Right? So here the position of the particle is continuously changes with respect to time and also with respect to surrounding. Okay, so this particle is in moving condition, or the motion of the particle is said to be in motion. Right? Okay, actually there are two types of motion. One is uniform motion and the second one is non-uniform motion. There are two types of motion, uniform motion and non-uniform motion. Right. Motion means if the position of the particle is changes with respect to time or with respect to surrounding is known as motion. There are two types of motion, uniform motion and non-uniform motion. Uniform motion and non-uniform motion. Right. First we go for uniform motion. Okay. So suppose let us consider an object. Suppose which is at the position A, or at a time t equal to 0, the position of the object is at A. Right. Okay. After 1 second, the velocity of the particle is, suppose here the velocity of the particle is 0 meter per second. After 1 second, the position of the particle is changes, that is from the point A to B. Okay. At this point B, the velocity of the particle is, for example, 10 meter per second. 10 meter per second. Right. After another 1 second, the particle position becomes C. In this position also, its velocity is 10 meter per second. Right. After another 1 second, the position of the particle is D. Here also, its velocity is 10 meter per second. 10 meter per second. Right. Here, the position of the particle is continuously changes with respect to surrounding. So the object is in moving condition or moving state. Right. And one more thing, here in all the position or all the time, the velocity of the particle is a constant. That is a 10 meter per second, 10 meter per second, 10 meter per second. Right. So if the velocity of the particle is a constant at every instant or at every position, okay, then the motion of the object is said to be uniform. Right. So if the motion of the object is said to be uniform if the velocity of the particle at every instant is the same. or the velocity of the particle is a constant. Understand? Right? If the velocity of the particle is a constant at every instant, then the motion of the particle is said to be uniform. Right? So in this diagram, it is clear that at position A, at position B, at position C, D, okay, in all the position, the velocity of the particle remains a constant. Right? Here also 10 meter per second. Right? At A, the velocity of the particle is 10 meter per second. At the position B, 10, C, 10, D, 10. Okay, time interval 1 second, 1 second, and 1 second. Right? Here the object position is continuously changes with respect to time. So the object is in a moving condition, or the object is said to be in motion. And this kind of motion is called uniform motion. Uniform motion. Why? Because the velocity of the particle remains a constant. The velocity of the particle remains constant. Right. For uniform motion, the acceleration of the particle is 0. In the case of uniform motion, the particle never possesses acceleration. Okay, why? Because acceleration is nothing but the rate of change of velocity. The rate of change of velocity is called acceleration. The particle experiences an acceleration only if the velocity of the particle changes. If the velocity of the particle changes, then only the particle experiences acceleration. Otherwise, the acceleration of the particle is 0. Here, suppose at position A, the initial velocity of the particle is 10 meter per second. Right. At position B, the final velocity of the particle is, for example, 10 meter per second. Right. Here, the velocity of the particle remains constant. So that is why this type of motion is called uniform motion. Okay. In the case of uniform motion, the acceleration experienced by the particle is 0. The acceleration experienced by the particle is 0. Because acceleration A is equal to V minus U. V final velocity, U initial velocity, and T time or time interval. Right. Here initial velocity is 10 meter per second. The final velocity, okay, 10 meter per second. Right. V minus U is called change in velocity. Change in velocity. So V value 10, U value 10, and time, okay, interval between the points B and A is 1 second. This is 0. So 1 minus 0, 1. So 10 minus 10, 0. So 0 divided by anything, 0. So acceleration experienced by the particle is 0. When? If the particle undergoes uniform motion. If the particle undergoes uniform motion, the acceleration of the particle is 0 because the velocity of the particle remains constant. When the particle experiences an acceleration, only the velocity of the particle changes. Otherwise, acceleration value is 0. In uniform motion, the particle velocity is a constant. V is a constant. But acceleration value is 0. Acceleration is generally represented by a small letter A, and velocity is represented by small letter V. Right. So V value is a constant and acceleration A value is 0 in the case of a uniform motion. So this is one type of motion. Right. And second, non-uniform motion. Non-uniform motion. Right. In the same diagram, suppose at the position A or in the time t equal to 0, the velocity of the particle is suppose V1 equal to 10 meter per second. Right. Okay, after 1 second, the particle reaches the point B with a velocity of 25 meter per second. With a velocity of 25 meter per second. Right. Okay, and after another 1 second, the particle reaches the point C with a velocity of 40 meter per second. 40 meter per second. Right. After one more second, the particle reaches the point D with a velocity of 55 meter per second. 55 meter per second. Right. The time interval, okay, between the point A and B and A is 1 second. Here also time interval 1 second. Here also time interval 1 second. Right. But what about the velocity of the particle at the position A, B, C and D? At position A, the velocity of the particle is 10 meter per second. At the position B, 25 meter per second. At the position C, 40 meter per second. At the position D, 55 meter per second. Right? In this case, the velocity of the particle, okay, at every instant is different, not constant. Not constant. Okay, here the position of the particle is continuously changes with the time. So here also the particle is in moving condition or in moving state, but the velocity of the particle is not constant. So this type of motion is known as non-uniform motion. Non-uniform motion. Are you understand what is the difference between uniform motion and non-uniform motion? In uniform motion, the velocity of the particle remains constant. In the case of a non-uniform motion, the velocity of the particle at every instant changes. Every instant changes, right? Okay. What is the acceleration of the particle in non-uniform motion? The acceleration is not equal to 0. In the case of uniform motion, the acceleration possessed by the particle is 0 because the velocity of the particle in the uniform motion is constant, right? But in non-uniform motion, velocity is not constant. So the particle experience an acceleration. So acceleration value is not equal to 0. Acceleration value is not equal to 0, right? So this type of motion is called non-uniform motion. Non-uniform motion, right? Non-uniform motion is also called accelerated motion. Non-uniform motion is also called accelerated motion because in non-uniform motion the particle possesses an acceleration. Why? Because the velocity of the particle is not constant, it continuously changes with the time. Continuously changes with the time. So there is a change in velocity, so the particle possesses acceleration, and the object is in moving condition or the object is said to be in motion. Such kind of motion is called non-uniform motion. Non-uniform motion is also called accelerated motion. In uniform motion, the velocity of the particle is constant, so acceleration value is 0. In non-uniform motion, the velocity of the particle is not constant, so acceleration value is not equal to 0. Non-uniform motion is also called accelerated motion. Accelerated motion. Okay, accelerated motion. There are two types of accelerated motion. There are two types of accelerated motion. One is uniform accelerated motion. Right. Second one is non-uniform accelerated motion. Right? In the previous stage we discussed about motion. There are two types of motion, uniform motion and non-uniform motion. In uniform motion, the velocity of the particle is constant. In non-uniform motion, the velocity of the particle is not constant. It changes. Non-uniform motion is also called accelerated motion. The accelerated motion are of two types. One is uniform accelerated motion. Second one is non-uniform accelerated motion. Non-uniform accelerated motion. Once again, we consider an object, which is moving along this direction with the different velocities. For example, 10 meter per second, 30 meter per second, 80 meter per second, and 150 meter per second. The point A, B, C, D respectively at time t equal to 1 and t equal to 2 seconds and t equal to 3 seconds and t equal to 4 seconds. Right. Here the velocity of the particle is not constant, it is changes. So this type of motion is called non-uniform motion or accelerated motion. Right. Okay, so there are two types of accelerated motion, uniform accelerated motion and non-uniform accelerated motion. Non-uniform accelerated motion. Right. Okay, here the particle velocity at the position A is 10 meter per second and particle velocity at B is 30 meter per second and the particle velocity at C is for example 50 meter per second. The particle's velocity at the position D is 70 meter per second. 70 meter per second. Right, at the position A, the particle's velocity 10 at the position B 30, at the position C 50, at D 70 meter per second. 70 meter per second, right? So what is the acceleration experienced by the particle in the time interval? Okay, 1 second. That is 2 seconds minus 1 second, 1 second. So what is the acceleration possessed by the particle during this time interval? How can we calculate? By using the formula A is equal to V minus U divided by T. A is equal to V minus U divided by T. Suppose this is taken as V1 and this is taken as V2. Right? The time interval is 2 minus 1, 1 second. 1 second. Right? Okay, here the acceleration possessed by the particle during this time interval is taken as A1. So A1 is equal to V2 V minus V1 divided by T. V1 is initial time and V2 is final time and T is a time interval. Right? Here, what is V2 value here? 30. What is V1 value? 10. And time interval 2 seconds minus 1 second, 1. So 30 minus 10, 20. So 20 divided by 1, 20. So 20 meter per second square. The acceleration of the particle during this time interval is A1, which is equal to 20 meter per second square. 20 meter per second square, right? And what is the acceleration possessed by the particle, okay, during this motion or during this time interval, right? Suppose let it be V2. The velocity of the particle at the position B is denoted by V2. Its value is 30 meter per second. The velocity of the particle at the position C is taken as V3. Its value is 50 meter per second, right? Once again, the acceleration during this time interval is that is taken as A2 and it is given by V3 minus V2 divided by T. Right? Here time interval 3 second minus 2 second, 1. And V3 value is final velocity. So final velocity is 50 and initial velocity is V2, that is 30. So 50 minus 30, 20. So 20 divided by 1, 20. So 20 meter per second square. Right? The acceleration possessed by the particle during this motion or during this time interval also 20 meter per second square. 20 meter per second square. Right? Finally, okay, during the motion from the point C to D, the acceleration possessed by the particle is taken as A3. At the position D, the velocity of the particle is taken as V4. So this is final velocity and this is initial velocity. And time interval is 4 second minus 3 second, 1 second. Right? Here acceleration is V4 minus V3 divided by T. Time interval is 1 and V4 value is 70 and V3 value is 50. Right? 70 minus 50, 20. 20 divided by 1, 20. So 20 meter per second square. Right, here the velocity of the particle is changes with respect to time. So that is why this type of motion is called accelerated motion or non-uniform motion. And one more thing here, the change in velocity of the particle with respect to unit time. Unit time means if time value is 1 second means then it is called unit time. So for every 1 second, the change in velocity of the particle is 20 meter per second. The change in velocity of the particle is 20 meter per second. If the change in velocity of the particle for unit time is a constant means, then the motion of the particle is said to be uniform accelerated motion, or the accelerated motion is said to be uniform when if the change in velocity for unit time is a constant. The change in velocity for unit time is a constant. V2 minus V1 is a constant. Then the accelerated motion is called uniform accelerated motion. The accelerated motion is said to be uniform if the change in velocity of the particle is a constant. Here the change in velocity is 30 minus 10, 20. Here the change in velocity V3 minus V2 value also 50 minus 30, 20. Here the change in velocity, that is V4 minus V3, is 70 minus 50. This is also 20. Right, here the change in velocity for unit time. Unit time means 1 second. Okay, if the change in velocity of the particle per unit time is a constant, then the accelerated motion is said to be uniform. Accelerated motion is said to be uniform. Right? Listen. There are two types of accelerated motion. One of them is uniform accelerated motion. Okay. Why it is called uniform accelerated motion? Because the change in velocity per unit time is constant. So that is why this accelerated motion is called uniform accelerated motion. Uniform accelerated motion. Right. And next we go for non-uniform accelerated motion. Non-uniform accelerated motion. Right. Again, we consider an object which is moving along the positive x-axis direction, right, with the velocities 10 meter per second, 40 meter per second, and 60 meter per second, and 95 meter per second. 95 meter per second, right, at the positions A, B, C, and D. In the time T1, time T2, T3, and T4. Right? T1 value is 1 second, and T2 is 2 second, and T3 is 3 second, and T4 is 4 second. Right? Suppose these velocities are taken as V1, V2, V3, and V4. Right? Here the velocity of the particle is changes with the time. So this type of motion is called accelerated motion. Accelerated motion, right? So in this accelerated motion, the change in velocity of the particle with respect to time, with respect to unit time, is not constant. The change in velocity of the particle with respect to unit time is not constant, right? So during this motion, the change in velocity is V2 minus V1. V2 minus V1. So V2 value is 40 and V1 value is at 10. So change in velocity is 30 meter per second. 30 meter per second, right? Time 1 second. The time interval is 1 second, right? So 1 second means unit time, right? So during this motion, the change in velocity is V3 minus V2. V3 minus V2, right? V3 value is 60 and V3 value is 40, right? So 60 minus 40, 20 meter per second, right? If the particle moving from A to B, its change in velocity is 30 meter per second. The same particle moving from the position B to C, its change in velocity is 20 meter per second. 20 meter per second. And during this motion, the change in velocity is V4 minus V3, and V4 value is 95 and V3 value is 60, right? So 95 minus 60, 35 meter per second. 35 meter per second. If the same particle moving from the position C to D, its change in velocity is 35 meter per second. From A to B, change in velocity 30 meter per second. From B to C, the change in velocity is 20 meter per second. From C to D, the change in velocity of the same particle becomes 35 meter per second. Here, the change in velocity is not constant per unit time. Okay, so this type of accelerated motion is called non-uniform accelerated motion. Non-uniform accelerated motion. Are you clear? In uniform accelerated motion, the change in velocity per unit time is constant. In the case of non-uniform accelerated motion, the change in velocity per unit time is not constant. The change in velocity per unit time. Change in, not velocity, change in velocity per unit time. Per unit time means 1 second. So for every 1 second, the change in velocity of the particle is not constant in the case of a non-uniform accelerated motion. But the particle possesses acceleration, both cases. In uniform accelerated motion, in non-uniform accelerated motion, the particle possesses or experience an acceleration. But the only difference is that in uniform accelerated motion, the change in velocity per unit time is constant. In non-uniform accelerated motion, the change in velocity per unit time is not constant. So this is the main difference between uniform accelerated motion and non-uniform accelerated motion. Already I told what is meant by acceleration. acceleration is nothing but the rate of change of velocity. Acceleration is denoted by A. It is given by V minus U divided by T. V final velocity, U initial velocity. V minus U is called change in velocity. V minus U divided by T is called the rate of change of velocity. The rate of change of velocity is called acceleration. The rate of change of velocity is called acceleration, right? We know what is the unit of velocity. The unit of velocity is meter per second, right? The unit of time, second. So, meter per second square or meter second power minus 2. This is a SI unit of acceleration. SI unit of acceleration. Okay, in which system? In SI system. In SI system or in MKS system, the unit of acceleration is meter second power minus 2 or meter per second square. Meter per second square, right? In CGS system, CGS system, the unit of acceleration is centimeter second power minus 2. Right? Centimeter second power minus 2. In SI system, the unit of acceleration is meter second power minus 2. In CGS system, the unit of acceleration is centimeter second power minus 2. Centimeter second power minus 2. And what is the dimensional formula for acceleration? Dimension. So these two are units in SI system and the CGS system. And the dimension of acceleration is m power 0, L power 1 and T power minus 2. The dimensional formula for acceleration is m power 0, okay, and L power 1 and T power minus 2. Mass has no dimension and length has only 1 unit and time has minus 2 units. So this is dimensional formula for acceleration. Dimensional formula for acceleration, right? Okay, and acceleration is a vector quantity. Acceleration is a vector quantity. What is vector? If any quantity that has both magnitude and direction. If any physical quantity that possesses both magnitude means some numerical value, and it possesses some direction, the quantity has some definite direction means, then the quantity is called vector quantity. Vector quantity. So one of the vector quantity is acceleration. Okay. So acceleration is nothing but the rate of change of velocity. Its unit is meter second power minus 2 in SI system and centimeter second power minus 2 in CGS system. And its dimensional formula is m power 0, L power 1 and T power minus 2. What is dimensional formula? The power of fundamental quantity is nothing but the dimensional formula, right? So m power 0, L power 1 and T power minus 2 or L T power minus 2 is the dimension of acceleration or dimensional formula of acceleration. And acceleration is a vector quantity because it has both magnitude and direction. Both magnitude and direction, right? And acceleration are of two types. One is average acceleration and second one is instantaneous. Right, acceleration are of two types, average acceleration and instantaneous acceleration. Instantaneous acceleration. Right, what is average acceleration? The ratio of change in velocity per unit time or the change in velocity over a time interval del t. Over a time interval del t is known as average acceleration. The average acceleration of the particle is defined as the ratio of change in velocity over the time interval del t is known as average acceleration. Right? For example, again, suppose let us consider a particle. Its velocity is changes from v1 vector to v2 vector in a small interval of time, that is a del t, or t2 minus a t1, t2 minus t1, right? So there is a particle whose velocity is changes from v1 vector to v2 vector, okay? Because velocity also vector quantity. Here the velocity is written in vector form, that is v1 vector and v2 vector. The particle velocity is changes from v1 vector to v2 vector in the time interval del t. So del t is equal to t2 minus t1. What is t1 and t2? The velocity of the particles v2 and v1 and v2 at the time t1 and t2. T1 and T2. So change in velocity is T2 minus T1. The T2 minus T1 can also be written as del T. So del T is change in velocity. Change in velocity, right? Okay. Already I told average acceleration is defined as the ratio of change in velocity. The change in velocity over the time interval del T is known as average acceleration. The average acceleration is denoted by like this, average acceleration, which is equal to ratio of change in velocity v2 vector minus v1 vector. What is change in velocity? Final velocity minus initial velocity is called change in velocity. Here final velocity is v2 and initial velocity is v1. So that is why v2 vector minus v1 vector in the time interval or over the time interval del t. Over the time interval del t, or v2 vector minus v1 vector divided by t2 minus t1. t2 minus t1, or del v vector divided by del t. So average acceleration is given by the formula del v vector divided by del t, or v2 vector minus v1 vector divided by t2 minus t1, or v2 vector minus v1 vector divided by del t. So from this equation, average acceleration can be defined. It is defined as the ratio of change in velocity over the time interval del t. Over the time interval del t. And average acceleration is also vector quantity. So that is why I am written in vector form. And its direction along the direction of del v vector. Along the direction of del v vector. It means the direction of acceleration is in the direction of a change in velocity. Is in the direction of change in velocity. So average acceleration also vector quantity. Its direction is along the direction of a change in velocity. That is a del v vector. Average acceleration direction is along del v vector. Average velocity is the direction is along del v vector. Right? Acceleration is two types: average acceleration and instantaneous acceleration. Average acceleration is denoted by like this. It is defined as ratio of change in velocity over the time del t. Over the time del t. Okay, and average velocity can be written as v2 vector minus v1 vector divided by del t, or v2 vector minus v1 vector divided by t2 minus t1, or del v vector divided by del t. Del v vector change in velocity and del t change in time. The ratio of del v vector divided by del t gives average acceleration. Average acceleration is a vector quantity. Then what is its direction? Its direction is in the direction of del v vector. Is in the direction of del v vector. Next acceleration, instantaneous acceleration. Instantaneous acceleration. Instantaneous acceleration is nothing but the simple the acceleration of the particle at any instant. The acceleration of the particle at any instant is called instantaneous acceleration. Instantaneous acceleration, or otherwise defined as the ratio of change in velocity, over the time interval del t, as del t tends to becomes zero. As del t tends to becomes zero. Okay, del t approaches zero, but not del t value is zero. Right? If del t almost approaches zero, then the type of acceleration is called instantaneous acceleration. Instantaneous acceleration. So we have two definitions of instantaneous acceleration. First one, The acceleration of the particle at any instant is called instantaneous acceleration. It is also defined as the ratio of change in velocity over the time at del t as del t tends to becomes 0. As del t tends to becomes 0. Right? Simply the instantaneous acceleration is denoted by A vector. Okay. AVG vector is called average acceleration. Average acceleration. But instantaneous acceleration simply we can written as A vector. A vector. Right. Which is equal to limit del B vector divided by del T as del T tends to becomes 0. As del T tends to becomes 0. So del T approaches 0. Then the ratio of a change in velocity over the time interval del T is called instantaneous acceleration. Instantaneous acceleration, or A vector is equal to limit del T tends to becomes 0, V2 vector minus V1 vector divided by del T, or otherwise del T can be written as T2 minus T1. Right here del T tends to becomes 0. And this type of acceleration is called instantaneous acceleration. Average acceleration is V2 vector minus V1 vector divided by del T. Here del T value is not tends to becomes 0. But in the case of instantaneous acceleration, del T tends to becomes 0. So del T value is not exactly 0. It close to 0. Close to 0. And in that case, the acceleration is called instantaneous acceleration. Instantaneous acceleration, right? So both the average acceleration and instantaneous acceleration are vector quantity whose direction is along the direction of v vector or along the direction of del v vector. Along the direction of del v vector. So once again repeat, average acceleration is defined as the ratio of change in velocity over the time interval del t. Over the time interval del t. And instantaneous acceleration is defined as the ratio of change in velocity over the time at del t as del t tends to becomes 0. As del t tends to becomes 0 is called instantaneous acceleration. So there are two types of acceleration, average acceleration and instantaneous acceleration. Right, already I told there are two types of acceleration, average acceleration and instantaneous acceleration. There is a simple difference between average acceleration and instantaneous acceleration, right? The average acceleration will give only the change in velocity of the particle over the time interval del t, over the time interval del t. But the average acceleration does not give the acceleration of the particle at any instant. At any instant, it gives the average acceleration gives the change in velocity of the particle over the time interval del t, that is t2 minus t1. But the average acceleration does not give the acceleration of the particle at any instant. At any instant t. Right. For that situation, we go for instantaneous acceleration. Instantaneous acceleration. So instantaneous acceleration is defined as the ratio of change in velocity of the particle over the time interval del t as del t tends to becomes 0. As del t tends to becomes 0. So this is the main difference between average acceleration and instantaneous acceleration. Instantaneous acceleration. Right. So the formula of acceleration already written, A vector is equal to V vector minus U vector divided by t. So this is a general equation for acceleration. Right, A vector, acceleration is a vector quantity, velocity also vector quantity, but a time scalar quantity. So that is why the equation of acceleration is written as A vector is equal to V vector minus U vector divided by t. Right. The acceleration equation can also be written in component form. Component form. Right, the component form of acceleration is A vector is equal to, right, del V vector divided by, dv vector divided by dt. A vector is equal to dv vector divided by dt. Right, rate of change of velocity is called acceleration. Right. The v vector in component form can be written as vx I cap, vy j cap, and v is at k cap. V is at k cap. I cap, j cap, k cap, these three are unit vectors of three component, three coordinate axes, that is x-axis, y-axis and z-axis. They are called orthogonal unit vectors. I cap, j cap, k cap or orthogonal unit vectors, or the unit vectors of three coordinate axes, that is x-axis, y-axis and z-axis. Right. What is vx, vy and vz? Vx, vy, vz. These three are scalar components of v vector. Scalar components of v vector. That is, the velocity of the particle along x direction is denoted by vx. The vx gives only the magnitude of velocity of the particle along x-axis direction or x direction, right? And vy, the scalar component of v vector, the scalar component of v vector. So vy gives the velocity of the particle in y direction, and vz is a scalar component of same v vector. It gives the magnitude of velocity of the particle along z direction. So that is why vx, vy and vz, these three are scalar components of v vector. I cap, j cap and k cap, these three are orthogonal unit vectors. Or orthogonal means perpendicular. Okay, because in three-dimensional space, the three dimension is generally described by three coordinate axes, x-axis, y-axis and z-axis. Like this. This is x, this is y and this is z. Its unit vector is represented by I cap, its unit vector is represented by j cap and its unit vector is k cap. Angle between I cap and j cap 90 degree, angle between j and k 90 degree, angle between k and I is 90 degree. So that is why they are called orthogonal. Orthogonal means a perpendicular unit vector. Perpendicular unit vector, right? The component form of velocity is v vector is equal to vxi cap, vy j cap and v is plus vz k cap, right? Put v vector is equal to vxi cap, vy j cap and vz k cap here. Then this equation becomes a vector is equal to d divided by dt of vxi cap plus vy j cap plus vz k cap, right? Or a vector is equal to d vxi cap divided by dt plus d vy j cap divided by dt plus d vz k cap divided by dt. A vector equal to d vx I cap divided by dt plus d vy j cap divided by dt plus d vz k cap divided by dt. So this is one of the component form of acceleration. Component form of acceleration, right? Or a vector is equal to ax I cap plus ay j cap plus az k cap. Az k cap, where ax, ay, az, these three are scalar components of a vector. I cap, j cap, k cap, these three are orthogonal unit vectors. Right here, ax is equal to dvx divided by dt. And ay is equal to dvy divided by dt. And az is equal to dvz divided by dt. Az is equal to dvz divided by dt, ay is equal to dvy divided by dt, and ax is equal to dvx divided by dt. Ax, ay, az, these three are scalar components of a vector. Scalar components of a vector. Right. So a vector is equal to ax I cap, ay j cap plus az k cap, or dvx I cap divided by dt plus dvy j cap divided by dt plus dvz k cap divided by dt. Right. So both are component form. Component form of acceleration. Component form of acceleration is a vector equal to ax I cap, ay j cap plus az k cap, or a vector is equal to dvx I cap divided by dt plus dy j cap divided by dt plus dvz k cap divided by dt. Right. So combine all these three terms, we can get a vector is equal to dv vector divided by dt. A vector is equal to dv vector divided by dt. Right. From this it is clear that acceleration is nothing but first derivative of velocity with respect to time. First derivative of velocity with respect to time, or first derivative of velocity gives acceleration of the particle. Acceleration of the particle, right? Okay, and next we know that V vector is equal to Vxi cap plus Vyj cap plus Vz k cap. Vz k cap, right? So what is Vx, Vy and Vz? Scalar components of V vector. Scalar components of V vector. Generally what is velocity? Velocity is nothing but the rate of change of displacement. Rate of change of displacement, right? So V is equal to dx divided by dt. V is equal to dx divided by dt, or dr divided by dt. Dr divided by dt. Here r is a position vector. So the position vector with respect to time gives velocity, or change in position vector with respect to time gives velocity, right? The position vector, also vector quantity, its component form is r vector is equal to xi cap plus yj cap plus zk cap. R vector is a position vector. Its component form is xi cap plus yj cap plus zk cap, right? So V vector is equal to dr vector divided by dt. So this is vector form of velocity, and d divided by dt of r vector is equal to xi cap plus yj cap plus zk cap, right? V vector is equal to dxi cap divided by dt plus dy j cap divided by dt plus dz k cap divided by dt. Dz k cap divided by dt. Now substitute V vector equal to dxi cap divided by dt plus dy j cap divided by dt plus dz k cap divided by dt in this equation, right? Then this equation becomes A vector is equal to dv vector divided by dt, or d divided by dt of, instead of V vector, dxi cap divided by dt plus dy cap divided by dt plus dz k cap divided by dt, right? So dx I cap divided by dt plus dy j cap divided by dt plus dz k cap divided by dt, right? Or d divided by dt into dxi cap divided by dt is d square xi cap divided by dt, right? D divided by dt into dy j cap divided by dt is d square y j cap divided by dt square, dt square plus d into dz k cap d square z k cap dt into dt dt square, right? Okay, take d square divided by dt square. Here d square divided by dt square is common, so take outside. So d square divided by dt square of xi cap plus y j cap plus z k cap. After taking d square divided by dt square, a common value outside, we can get d square divided by dt square of xi cap plus yj cap plus zk cap, right? Xi cap plus yj cap plus zk cap is equal to r vector, right? So d square r vector divided by dt square is equal to a vector. So the acceleration of the particle is equal to second derivative of a position vector. The second derivative of a position vector with respect to time gives acceleration, or the first derivative of velocity with respect to time gives acceleration. Okay? So first derivative of velocity and the second derivative of a position vector, both of them gives the acceleration of the particle, that is instantaneous acceleration. Instantaneous acceleration. So there are two types of acceleration: average acceleration and instantaneous acceleration. What is average acceleration? The ratio of the change in velocity over the time interval del t is called average acceleration. And what is instantaneous acceleration? the ratio of change in velocity over the time at del t as a del t tends to become 0. Or simply we can define the acceleration of the particle at any instant. The acceleration of the particle at any instant. The component form of acceleration is in three forms. One is a vector is equal to ax I cap plus ay j cap plus az k cap. In terms of the scalar components of acceleration, the component form of acceleration can be written as a vector equal to ax I cap, ay j cap plus az k cap. In terms of velocities, scalar components of velocity, component form of acceleration can be written as a vector is equal to d vx I cap divided by dt plus d vy j cap divided by dt plus d vz k cap divided by dt. In the case of position vector or position vector of particle, the acceleration of the particle in component form can be written as a vector is equal to d square x I cap divided by dt square plus d square y j divided by dt square plus d square z k cap divided by dt square. So this is in terms of position vector along x-axis, y-axis and z-axis. This is velocity along the x-axis, y-axis and the z-axis, the acceleration component form. In the case of acceleration along the x-axis, y-axis and z-axis, the component form of acceleration is a vector is equal to ax I cap plus ay j cap plus az k cap. Alright, how can you calculate the acceleration? If you know the initial velocity, final velocity and the time, we can calculate what is the value of acceleration, right, by using the formula a is equal to v minus u divided by t. If you know initial velocity, final velocity and the time, by using this formula, we can calculate what is the magnitude of acceleration. Right. And the acceleration of the particle can also be determined from Vt graph. The acceleration of the particle can also be calculated or can also be determined from Vt graph. Vt graph means the velocity time graph. Velocity time graph. Right. From the Vt graph, we can calculate what is the magnitude of acceleration of the particle. Right. For example, if a time t1 equal to 0, where the velocity of the particle is 0. The velocity of the particle is 0. If a time t2 is equal to 1 second, the velocity v2 becomes, for example, 10 meter per second. At a time t3 is equal to 2 second, the velocity 20 meter per second. v3 is equal to 20 meter per second. And time t4 is equal to 3 second, and velocity v4 is equal to 30 meter per second. 30 meter per second, right. Now, taking the time along the x-axis and the corresponding velocity along the y-axis. Now, draw a graph by taking the time along the x-axis and velocity along the y-axis. Right. So, this is, see, if for time t equal to 0, the velocity value also 0. Right. This is 1 second. 2 second, 3 second and 4 second. 10 meter per second, 20 meter per second, 30 meter per second and this is 40 meter per second. Right. If time t equal to 0, velocity value also 0. Right. If time t equal to 1 second, the velocity value is 10. Time t equal to 2 second, velocity, so 2 second, the velocity is 20. And at 3 second, velocity value is 30. At time t equal to 4 second, the velocity is 40. Right? So taking time along the x-axis and corresponding velocity, okay, y-axis, okay, we can get a graph like this. That is a straight line, right? So this graph is called Vt graph. Vt graph. In the case of accelerated motion, I mean uniform accelerated motion, the nature of the graph can be happening like this, right? Okay, now take a slope in this graph, I mean VT graph. We know that the slope is equal to the change in quantity in the y-axis divided by the change in velocity, change in quantity in the x-axis. Change in quantity in the y-axis divided by change in quantity in the x-axis. That is dy divided by dx. Right. Here, which quantity is taken along the y-axis? Velocity. So, dv. And which quantity is taken along the x-axis? Time. So, dv divided by dt, slope. Right. So, here dv divided by dt is nothing but the acceleration. dv divided by dt is nothing but acceleration. So, in the velocity time graph, from the velocity time graph, we can calculate the acceleration of the particle. How? By taking slope. Okay? So, from this graph, just to take a slope, the slope of a velocity time graph gives the acceleration. The slope of velocity time graph gives the acceleration of the particle. Acceleration of the particle. Right. Suppose if we draw a graph by taking a time along the x-axis and acceleration along the y-axis. Acceleration along the y-axis. Suppose if the graph is acting like this. Right. For example, the graph is acting like this. Right. So what is the use of acceleration time graph? From the acceleration time graph, we can calculate what is the velocity of the particle over the time interval t2 minus t1. Over the time interval t2 minus t1. How? By measuring the area under this curve, in the AT time, I mean acceleration time graph, right? So by taking a slope in the VT graph, that is velocity time graph, we can calculate or we can determine what is the acceleration of the particle. Acceleration of the particle in VT graph, right? But in acceleration time graph, by measuring the area under the curve, the area under the curve in the acceleration time graph, okay, gives the velocity of the particle during the time interval t2 minus t1. During the time interval t2 minus t1. Right. We know that velocity is equal to, acceleration is equal to dv divided by dt. dv divided by dt. Therefore, dv is equal to a into dt. dv is equal to a into dt. Just to integrate on both sides. So, integration of dv is equal to integration of a into dt. Suppose the acceleration of the particle is constant. Okay. Then, integration of dv gives v. So, v is equal to a into t. So, the limit is taken from t1 to t2. So, in the acceleration time graph, from the acceleration time graph, by measuring area under the curve gives the velocity of the particle over the time interval t2 minus t1 or over the time interval del t. Over the time interval del t. So, the acceleration of the particle can be determined if you know final velocity, initial velocity and time. And acceleration of the particle can also be measured from velocity time graph by taking slope in that graph. And from acceleration time graph, we can find out what is the velocity of the particle over the time del t, or del t is equal to t2 minus t1. Or by measuring area under this curve. By measuring area under this curve in the acceleration time graph, we can calculate the velocity of the particle over the time interval t2 minus t1. Over the time interval t2 minus t1. Right. Based on the topics so far we discussed, some problems are there. Right. First problem, example problem 2.32. Right. Question is, if the position vector of the particle is given by r vector equal to 3t square I cap plus 5t j cap plus 4k cap. The position vector of the particle only given, that is r vector equal to 3t square I cap plus 5t j cap plus 4k cap. Right. From this, we need to find out what is the velocity of the particle at t equal to 3 seconds and speed of the particle at t equal to 3 seconds and acceleration of the same particle at the time t is equal to 3 seconds, right? The given value is only position vector. From this, we need to calculate velocity, speed and acceleration, right? First, what is the difference between velocity and speed? Velocity is nothing but rate of change of displacement, or rate of change of position vector is nothing but velocity. What is speed? The magnitude of velocity of the particle is called speed. The magnitude of velocity of the particle is called speed. By taking or by measuring the magnitude of a velocity, that value is called speed, right? So what is the given value in this question? Only position vector. Position vector R vector is equal to 3t square into I cap plus 5t into j cap plus 4k cap, right? So R vector, position vector, right? From this equation it is clear that this is time dependent position vector. Time dependent position vector. If the time value changes, automatically the position vector value also changes. So that is why this position vector is called time dependent position vector. Time dependent position vector, right? Okay, so the given value is only position vector. First, what we want to find out? Velocity. Velocity. Right, what is velocity? The first derivative of position vector is nothing but velocity. The first derivative of a position vector gives velocity, right? So v vector is equal to d divided by dt of r vector is given, that is 3t square I cap plus 5t j cap plus 4k cap. 4k cap. Now differentiate this position vector values. We can get v vector is equal to 6t into I cap, right? First to differentiate 3t square into I cap in terms of time. We can get 3 2s are 6, so 6t I cap, 6t I cap, right? Next 5t j cap, differentiate 5t j cap. By differentiating 5t j cap, we can get 5 into 1 into j cap, right? Next differentiate 4k cap. Here there is no time factor. By differentiating this value in terms of time, we can get 0, right? Here 0. So v vector is equal to 6t I cap plus 5j cap, 5g cap, right? So this is the velocity of the particle equation, time dependent velocity. Time dependent velocity, right? Okay, here what is the 6t? 6t is a scalar component of a v vector, that is along the x-axis, right? What is 5? 5, there is scalar component of velocity along the y-axis. Scalar component along the y-axis, that is vx is equal to 6t and vy is equal to only 5, right? So from this it is clear that vx only depends on time, but vy is not dependent on time. Vy value is always a constant. That value is 5 meter per second. 5 meter per second. But Vx is continuously changes with the time, because it depends on the time. If time value changes, automatically Vx value also changes. So this velocity has two components, two scalar components, that is Vx and Vy. So Vx component only time dependent, but Vy does not depends on time. It is independent of time. It is independent of time, right? So magnitude of v vector, velocity v vector is equal to 6. Okay, what we want to find out? The velocity of the particle at a time t equal to 3 seconds. 3 seconds. So substitute t is equal to 3 seconds here. Then v vector is equal to 6 times 3 into I cap plus 5 j cap. Right? 6 3s are 18. So 18 I cap plus 5 j cap. So this is the velocity of the particle at the time t equal to 3 seconds. The velocity of the particle at time t equal to 3 seconds is v vector is equal to 18 I cap plus 5 j cap. 5 j cap. Right. Second, what is the speed at a time, or speed of the particle at a time t equal to 3 seconds? Speed. What is speed? the magnitude of velocity gives speed. The magnitude of velocity of the particle gives the speed of the particle, right? And modulus of v vector is equal to, we know the rule, okay, modulus of v vector is equal to 18 square plus 5 square, okay? So v vector equal to 18 I cap plus 5 j cap. The magnitude of v vector is equal to square root of 18 square plus 5 square, right? 18 square, 18 into 18, 324, plus 5 square, 5 into 5, 25. So square root of 9, 4, 3. So speed is equal to square root of 349 meter per second. The magnitude of speed at a time t equal to 3 seconds is square root of 349 meter per second. The velocity of the particle at a time t equal to 3 seconds is v vector is equal to 18 I cap plus 5 j cap. Next, third, acceleration of the particle at a time t equal to 3 seconds. Right? C, acceleration. Acceleration a vector is equal to dv vector divided by dt. First derivative of velocity with respect to time is nothing but acceleration, right? A vector is equal to d divided by dt of the first derivative of position vector with respect to time gives velocity. The velocity obtained is 60 I cap plus 5 j cap. So substitute v vector value here, then d divided by dt of v vector is equal to 60 I cap plus 5 j cap. So differentiate these two terms, we can get 6 I cap plus 0, or a vector is equal to 6 I cap. Here acceleration has only one component. Here velocity has two components. Okay, one is Vx and another one is Vy. Vx is time dependent, whereas Vy is independent of time. Vy is independent of time. But here acceleration has only one component, that is only only one component, that is x component, right? Here, okay, 6 is ax, that is the scalar component of acceleration. One of the scalar component of acceleration is ax, that value is 6. So here the acceleration remains a constant because there is no time factor in this equation. So the acceleration of the particle is constant. It does not depend on time. So this is a simple problem. Only the position vector is given. From this velocity, speed and acceleration one should calculate at a time t equal to 3 seconds. Here velocity is 6 v vector is equal to 6 into 3, 18 I cap plus 5 j cap. So this is velocity, right? And modulus of v vector value gives speed. And speed value obtained is 349 meter per second, right? And third, acceleration is nothing but first derivative of velocity. By differentiating the velocity factor here, we can get a vector is equal to 6 I cap. So this is acceleration value. In this equation there is no time, so the acceleration of the particle is always constant. It is independent of time. It has only one component, whereas the velocity has two components. Right. Next problem, 2.33. Right. Question is, an object is thrown vertically downward. What is the acceleration? What is the acceleration experienced by the object? Right. If any object is dropped or thrown vertically downwards, the object experiences an acceleration due to gravity. Due to gravity or due to Earth's pulling, the object experiences an acceleration. So acceleration experienced by the object due to the gravity is denoted by G. Okay, that value is 9.8 meter per second square. Right? If any object is thrown vertically downwards, it experiences an acceleration due to gravity. The acceleration experienced by the particle due to gravity is denoted by G. Its value is 9.8 meter per second square. 9.8 meter per second square. Right? So for this question, we can draw a coordinate system like this. So this is negative x-axis and this is negative y-axis. Here an object is dropped vertically downward or thrown vertically downward, right? Here the object is moving along negative y-axis direction, right? In this situation, the acceleration experienced by the particle in vector form can be written as a vector is equal to minus g into j cap. A vector is equal to minus g into j cap. What is g? Acceleration experienced by the particle due to gravity. It is denoted by g. That value is equal to acceleration experienced by the object when it is thrown vertically downwards. So acceleration experienced by the particle when it is thrown vertically downwards is a vector is equal to minus g into j cap, because the particle is moving along negative y-axis direction, or a vector is equal to minus 9.8 j cap. So this is acceleration value. Example problem 2.31. A velocity time graph is given for a particle moving in x direction. A particle is moving in x direction. Its velocity time graph is given, right, in x direction as below, right? First, A, describe the motion qualitatively in the interval 0 to 55 seconds. Second, find the distance and displacement traveled from 0 to 40 seconds. Third, find the acceleration at a time t equal to 5 seconds and at a time t is equal to 20 seconds. From this velocity time graph, first we need to describe the motion qualitatively in the time interval 0 seconds to 55 seconds. Then the distance traveled by the particle and the displacement of the particle from the time interval 0 to 40 seconds. Third, finally, acceleration at the time t equal to 5 seconds and at the time t is equal to 20 seconds wants to find out, right? First, description of the motion qualitatively in the interval from 0 seconds to 55 seconds, right? So first we take O to A, that is from time 0 seconds to 10 seconds, right? So in this region, first, at a time t is equal to 0 second, the particle has a 0 velocity. At a time t is equal to 0 second, the particle has a 0 velocity. That is, the particle does not move, right? If the time is increases from 0, the velocity of the particle increases linearly. And attain a maximum value of 60 meters second power minus 1. Okay, 60 meters second power minus 1 at point E. At the point O, that is time t equal to 0, the velocity of the particle is 0. If time is greater than 0, the particle velocity increases linearly and attain a maximum velocity of 60 meters second power minus 1 at point E. Right? Okay, here the particle is moving in positive x-axis direction. Right? So in this region, if you take a slope, the slope value is positive. Slope is nothing but dy divided by dx. Okay, here the quantity which is taken in the y-axis is velocity. So dv. The quantity which is taken along the x-axis is time, so dt, right? Here dv divided by dt is a slope from O to A. Okay, the slope value is positive. Okay, from 0 to O to A, or from 0 seconds to 10 seconds, the slope value is positive, and the particle velocity increases linearly along positive x-axis direction, and reaches a maximum velocity of 60 meters second power minus 1 at point A or at 10 seconds. Right, from O to A or from 0 seconds to 10 seconds at a time t equal to 0, the particle velocity is 0. At time t is greater than 0, the particle velocity increases linearly. Then the slope value is positive in the region O2E, in the region O2E. If slope value is positive means the particle gets accelerated. The particle gets accelerated whose value also positive. Okay, so particle has a positive acceleration in the region from O to A. At a time t equal to 0, the velocity of the particle 0. If time is increases, the velocity of the particle also increases linearly along positive x-axis direction. X-axis direction, and the slope value is positive. If slope value is positive means the particle gets accelerated. Okay, whose value is positive. Right. From A to B. Next, A to B. Already I told at point A the particle velocity is maximum, that is 60 meters second power minus 1. If you go from A to B, the particle velocity remains a constant, that is 60 meters second power minus 1. So particle velocity is a constant means the particle acceleration is 0 because there is no change in velocity. The particle experiences acceleration only if the velocity of the particle is changes. But in the region from A to B, that is from 10 seconds to 15 seconds, 10 seconds to 15 seconds, the velocity of the particle is a constant. Particle velocity is constant. So the acceleration experienced by the particle in this region is 0. Acceleration 0, but the particle velocity is constant from the region A to B or from 10 seconds to 15 seconds. From 10 seconds to 15 seconds or from A to B, the particle velocity remains constant, that is 60 meters second power minus 1, and the velocity of acceleration of the particle is 0. Acceleration of the particle is 0. Right, from A to B, from A to B or from 10 seconds to 15 seconds, the particle velocity is a constant. The particle velocity is constant. The value is 60 meters second power minus 1. 60 meters second power minus 1. Right. If velocity is constant means then acceleration value is 0. Acceleration value is 0 because acceleration A is equal to dv divided by dt. The rate of change of velocity is nothing but acceleration. The particle has acceleration only if the velocity of the particle is changes. But from the region A to B, the velocity of the particle is a constant, so there is no change in velocity. So that is why the acceleration experienced by the particle is 0. The acceleration experienced by the particle is 0. Right. Next, from B to C or from 15 seconds to 30 seconds. From 15 seconds to 30 seconds. Right. At the point P, the particle velocity is 60 meters second power minus 1. Right. If the time is increases, greater than 15 seconds, okay, or greater than 15 seconds, the particle velocity is gradually decreases linearly and attain 0 velocity at the point C. At the point C. At point B, the particle velocity is a maximum. Okay. And after that, the velocity of the particle is gradually decreases and reaches 0 value at the point C. Reaches 0 value at the point C. Right. Okay. If we take a slope in this region, that is from B to C, okay, anywhere, the slope value is negative. Slope is negative. From O to A, slope value is positive. From B to C, the slope value is negative. If a slope value is negative means the particle velocity decreases. Particle velocity decreases. If the particle velocity is continuously decreases with the time, then the acceleration experienced by the particle becomes negative. The acceleration experienced by the particle becomes negative. That negative acceleration is called retardation or deceleration. The negative acceleration is called retardation or deceleration. Right. From B to C, or from 15 seconds to 30 seconds, right? At point B, the particle velocity is maximum, that is 60 meters second power minus 1, right? If a time value is greater than 50 seconds, the particle velocity is decreases linearly. The particle velocity is decreases linearly, right? And slope value in this region is a negative. The slope is a negative value, okay, from the region B to C, right? If slope value is a negative, then acceleration value also negative. The acceleration of the particle also negative, okay? So that acceleration is called deceleration or retardation. Deceleration or retardation. Next, from C to D. At point C, the velocity of the particle is 0. Okay, at point C, the velocity of the particle is 0. Or at 30 seconds, the velocity of the particle is 0. Right. After 30 seconds, the velocity of the particle is decreases, or the particle velocity is negative. The particle velocity is negative. Particle velocity negative means the particle moving in negative x-axis direction. Negative x-axis direction. Right. From O to A to B, B to C, the particle moves positive x-axis direction. Positive x-axis direction. Whereas from C to D, the particle moves negative x-axis direction. Negative x-axis direction, because the particle velocity is negative from the region C to D, and it reaches a maximum magnitude of 40 meter per second, 40 meter second power minus 1 at point D. At point D, right, from C to D region, or from 30 seconds to 40 seconds. At point C, the particle velocity is 0. After 30 seconds, the particle velocity is negative. That is, the particle moving in negative x-axis direction, and reaches a maximum magnitude of 40 meter second power minus 1 at the point D. At the point D. Right, from C to D, or from 30 seconds to 40 seconds. 40 seconds. The velocity of the particle is 0 at time t is equal to 30 seconds, or at the point C. At the point C, right? If t value is greater than 30 seconds, and velocity the velocity of the particle is negative. The velocity of the particle is negative. That means particle moving negative x-axis direction. Negative x-axis direction. And its velocity becomes 40 meter second power minus 1 at 40 seconds. At 40 seconds, or at the point D. At the point D, right, from C to D, or from 30 seconds to 40 seconds, at point C, or at a time t equal to 30 seconds, particle velocity is 0. And after 30 seconds, the particle velocity is gradually decreases in a negative x-axis direction. Negative x-axis direction. So that is why the particle velocity is negative, right? And reaches a maximum magnitude of 40 meter second power minus 1 at the time of 40 seconds, or at the point D. Next, from D to E, or from 40 seconds to 55 seconds. From 40 seconds to 55 seconds. Right. At D, the particle velocity is minus 40 meter second power minus 1. That is, magnitude value is 40 meter second minus 1. But the particle velocity is negative. After 40 seconds, or after 40 seconds, the particle velocity is increases, but still its value is negative, and reaches zero velocity at point E, or at 55 seconds. At 55 seconds. So from the region D to E, the particle velocity is still negative, okay, but its velocity is increases from minus 40 meter second power minus 1 to 0. At the point D, the particle velocity is minus 40 meter second power minus 1, and the particle velocity becomes 0 at the point E, or at 55 seconds. At 55 seconds, right? From D to E, or from 40 seconds to 50 seconds. 40 seconds to 55 seconds. Particle velocity is minus 40 meter second power minus 1 at the point D. At the point D. Then after 40 seconds, the particle velocity is still negative, but increases. The particle velocity is still negative but increases and reaches 0 meter second power minus 1. That is, particle comes to rest. Particle comes to rest where? At the point E. At the point E or at the time of 55 seconds. The time of 55 seconds or at the point E, the particle comes to rest. So the particle has a zero velocity. But at the point D, the particle velocity is negative maximum, that is minus 40 meter second minus 40 meter second power minus 1. If the time value is greater than 40 seconds, the particle velocity is still negative but increases, okay, and reaches the maximum value, that is 0 meter second power minus 1. That is, particle comes to rest at the point E or at the time t is equal to 55 seconds. Next question. Find the distance and displacement traveled from 0 seconds to 40 seconds. From 0 seconds to 40 seconds. Right? Distance and displacement traveled from 0 seconds to 40 seconds. First, distance traveled by the particle from 0 seconds to 40 seconds. We know that distance is a scalar quantity, so it does not depends on direction. So all the values are positive. All the values are positive, right? How can you calculate the distance traveled by the particle from 0 seconds to 40 seconds? By measuring the area under the curve in the velocity time graph. Okay, the area under the curve in the velocity time graph gives distance and displacement. Distance and displacement. The only difference is that in both the positive x-axis direction, the negative x-axis direction, the distance value is positive. But in the case of displacement, in positive direction, displacement is positive. In negative x-axis direction, the displacement is negative. So this is the difference between the distance and displacement, right, from velocity time graph. So first, distance traveled by the particle from 0 seconds to 40 seconds. From 0 seconds to 40 seconds or from O to D, okay, first from O to A or from 0 seconds to 10 seconds. From 0 seconds to 0 seconds to 10 seconds, this curve is a triangle. From 10 seconds to 15 seconds, this curve is a rectangle. Next, from 15 seconds to 30 seconds, triangle. From 30 seconds to 40 seconds, again triangle. Right. So there are 3 triangle and 1 rectangle. The sum of these area of 3 triangle and 1 rectangle gives the total distance traveled by the particle from 0 seconds to 40 seconds. Right. First, total distance traveled from 0 seconds to 40 seconds. 0 seconds to 40 seconds. Right, which is equal to first area of the first triangle, that is of BH1, and next area of the rectangle, so breadth and height. Next, area of the second triangle, suppose this is of BH2, and third triangle of BH3. Right, first area of first triangle, B value 10 minus 0, 10, and H value is 60 minus 0, 60. So of B value 10 and H value is 60. Right, plus in the rectangle, breadth value is 15 minus 10, 15 minus 10, so 5. And height value is 60 minus 0, so 60. So 5 into 60. Right. Plus the area of the second triangle. Okay, so this is first triangle, and this is second triangle, and this is third one. Right. Okay, area of the second triangle of here breadth value B to C. So this is 30 and this is 15. So 30 minus 15, 15. And next height value same 60. So area of the second triangle over. Then finally area of the third triangle, right, of B value 40 minus 30, 40 minus 30, 10. Height value is height value is 40. Okay, height value is 40 in this triangle. So into 40. Right, simplification. 5 times, 30 times, 5 times. So 5 into 60, 300. 5 into 60, 300. Next, 15 into 30, 450. And 5 into 40, 200. Right, 300 plus 300, 600. 600 plus 200, 800. And 800 plus 450, 1250 meter. So this is total distance traveled from the time 0 to 40 seconds. From the time 0 to 40 seconds, the total distance traveled by the particle is 1250 meter. 1250 meter. Right? How can we measure the total distance traveled from the velocity time graph? By measuring the area under the curve. Okay? Already I told, for distance measurement, if the particle moves along positive x-axis direction or along negative x-axis direction, whose value is positive. So that is why the total distance traveled value is positive, that is 1250 meter. Next, total displacement covered by the particle from 0 seconds to 10 seconds. Right, already I told the only difference between distance and displacement in the case of measurement of a distance, if the particle moving either positive x-axis direction or negative x-axis direction, the area value is taken as a positive. But while measuring a displacement, if the particle moving along positive x-axis direction, area positive, that is the displacement value is positive. But if the particle moving negative x-axis direction, the area value and as well as the displacement value is negative. So this is the difference, right? So now the total displacement traveled by the particle from 0 seconds to 40 seconds. Right? Same area under the curve in the velocity time graph gives displacement. Right? Here the particle moving positive x-axis direction, so this area is taken as positive. From A to B, the particle moving positive x-axis direction, so displacement positive. From B to C, the particle again are still moving positive x-axis direction, so this area and as well as this displacement is taken as positive. But from C to D, the particle moving negative x-axis direction, so the displacement value is negative. So this is negative. And this value also negative, right? So the total displacement traveled by the particle from 0 seconds to 40 seconds is 300 plus 300, 600, 600 plus 450, 1050, 1050 minus 200, 850. So this is total displacement. The total distance traveled by the particle from 0 seconds to 10 seconds is 1250 meter. Whereas the total displacement covered by the particle from 0 seconds to 10 seconds is 850 meter. Right. C. Find the acceleration at time t equal to 5 seconds and at time t equal to 20 seconds. Right. From velocity time graph, the acceleration experienced by the particle can be determined by taking slope. Right. In this question, find the acceleration experienced by the particle at a time t equal to 5 seconds and t equal to 20 seconds. T equal to 20 seconds and t equal to 5 seconds. T equal to 5 seconds. Right. In this diagram, from O to A or from 0 seconds to 10 seconds, the slope is positive. The slope value gives acceleration. And one more thing, the acceleration of the particle from the region O to A is always a constant. At A, at O, and also in between 0 seconds to 10 seconds, the acceleration of the particle is always constant. So, okay, slope is equal to acceleration experienced by the particle, right? Slope equal to dy divided by dx or dv divided by dx. Sorry, d and dx here dt, right? So dv or v2 minus v1, dt or t2 minus t1, t2 minus t1, right? So here in this slope, initial velocity, that is v1 value is 0 and final velocity v2 is 60 meters second power minus 1, right? Initial time 0 second and final time 10 second. So v2 value 60 and v1 value is 0 divided by final time is 10 second and initial time is 0. So 60 minus 0, 60, 10 minus 0, 10. So 6 meters second power minus 2. So the acceleration experienced by the particle from the region O to A is constant, that value is 6 meters second power minus 1. So the acceleration at a time t equal to 5 seconds also 6 meters second power minus 1. Next, the acceleration experienced by the particle at a time t equal to 10 seconds, 20 seconds, at time t equal to 20 seconds, right? In the region that is from B to C, the slope is negative, that is the acceleration experienced by the particle also negative, right? And also in this region, the acceleration of the particle is negative and also constant, Once again, slope equal to dv divided by dt. Slope gives acceleration. So dv is nothing but v2 minus v1 and dt is t2 minus t1, right? From B to C. Here final velocity is 0 but initial velocity is 60 meters second power minus 1, that is v1 value is 60 and v2 value is 0. And final time is 30 and initial time is 15. So final velocity 0, initial velocity 60 divided by final time is 30, and initial time is 15, minus 60 divided by 30 minus 15, we can get minus 4 meters second power minus 2. So from the region B to C, the particle has a negative acceleration and also constant value. So the acceleration experienced by the particle at a time t equal to 20 seconds also minus 4 meters second power minus 2.